Hello, how are you? Assalamu alaikum, everyone. I hope you are nice today and going well. Uh, Today we are, as we speak in our last lecture, we speak about AI and machine learning, difference between AI and machine learning, deep learning, okay, supervised and unsupervised data. Uh, and so we are going today to contain our subject here. So we are going to speak about the most fundamental topic in machine learning, regression. This lecture will walk from the basic idea of the linear regressions, okay, to going deeply here, to speak deeply then about advanced level of linear regression, such like range regression, lasso, elastic net, and even for nonlinear nonlinear variables or features which are in neural network. So again, we are going to consider the linear regressions, which were considered by one variables or one futures. Then we are going to consider multi-futures in our study. We are going to include GT and or coordinate distinct variant or repetition of the linear regression, complexity of this model, and so on. So this slide here will give here us any question before we start.
Just one question, please. Doctor, you told us that after we finish the chapter 1, the announcement, the assignment, what one will be assigned to be announced?
The assignment will be announced after the lecture, inshallah. We will get the first assignment about the linear regression.
Thank you so much.
Okay, so this slide here, this slide gives us the roadmap. We will start the simple linear regression by one input variable or input future, and then by considers monthly inputs. Then we are going to consider the Gardinian distinct, and then and its variant, look at the limitations of linear regression, talk about the model complexity and biases and variance, okay. Actually, then we are going to look like a neuron inside PyTorch, basically. We will go from math to machine learning implementations. This is here just here an overview about the topic. So what is the concept of linear regression? Did you know what is linear regression? I think everyone know what is linear regression. It's come from statistical concept, okay. It's a line, okay, which determine the relationship between dependent variable and independent variable. Okay, so this relationship could be increasing or decreasing and represented by this line. Okay, so if we have positive slope, okay, so it will be go up, and if we have negative slope in mathematically way, okay, so it will be go down. As we see here, we here determine the relationship between the input variable was here a lot of input variables, okay. For example, the quality from 1 to 10, the conditions, okay, from 1 to 10 scale, the ground leaving area in the square feet, okay. And then we have here a central error and then the total basement size. Okay, the output is the price. Okay, the price of this. Okay, so we fit all this future into the model, and the regressions will learn a line or hyperplane. Okay, as we see that is best predicate the price. Okay, so it will be best predicate the price. So you will see this data set. Okay, I'm how think, for example, of used to. It will be here in our first exercise or assignment. I'm scouting. It's usually used to predict the price of the house. Okay, it's simple, but it's very realistic. Okay. The second here application, it's come from medical size. Okay. Okay. Medical application, we have the variable in TAF, normalized total, Azorma value, volume measure, lake Q, built up inside R series using intra-fascicular or intrasound. Okay, it's a quantitative variable, as we see here, meaning the regression can help us understand how factors like age or cholesterol level the inflow or the level of the NTAF. Okay, so see how NTAF are affected or increases with the age. Okay, slightly.
Yes, Doctor, based on
The trend, they're showing the trend. They showing out the trend. Okay, and how it's affected by the age. Okay, how trained. Okay, for example, by male and female, and here in general. Okay, so third application which we can speak about here, as we see here, this is one from cancer research. Okay, cancer research here we have scientists use human breast cancer cell, okay, MCF7, and test 3 drugs. Okay, three different drugs. Okay, as we see here. Which drugs we have? We have here Givastive, okay, this is the first one, then fourth meaning, okay, and then we have the third one is UO or U0126, okay, and they measure here, okay, they found that the response of the parameters and enhance the combinations of drugs can be accurate, okay, and describe using linear combinations of the response of each drug individually. That means regression and action predict combined effect from individual one. Okay, so even in biology, linear model can capture meaningful pattern. Okay, as we see. So so combining and single treatment. So we have combined treatment only and not additive. Okay, so in the different colors. Okay, the different colors. So the blue are representing the combined and single treatment, and the red represents combined treatment only, and the gray one represents not. So any question? Is it clear?
No, thank you.
Okay. So let us here now go to one linear regression considering by one input or one variable, one features. So we will have this simple thing here. So what is here regression model? Regression model, okay, actually, okay, when we have here, okay, linear model from non-linear model, okay, at first. What we mean by linear model? Linear model, it's linear relationship, okay? So we have B0, okay? We have this here relationship. Okay, we have here this relationship here. When we speak about linear relationship, that we have y equal fixed number b0, for example, plus b1 x1 and plus b2, okay, x2. This is a linear combination. Okay, so it's a linear combination. Okay, if we have non-linear, what it means? That means we will have non-linear function inside. Okay, that means we have b0, for example. Okay, then we come here, then b1 cosine, for example. Cosine log.
Yes.
Okay, and another function, which are non-linear function. Okay. So this is the difference between a linear and non-linear function at first. Okay, this is the most simple idea to understand the difference. Okay, between linear and non-linear function. So as we see here, we have here only one variable. Okay, so x is 1 and y, and we are going to study here the relationship between x and y. So we have here not x1, x2, we have only one, b0 plus b1, x1.
The simple relation.
So it's simple relation. So without this part, for example. Okay,
Yes.
this is here one input. Okay, one input. So B0, it will be the intercept in mathematically way, and B1 will be the slope, okay, which can be positive or negative. Okay, so again, okay, so B0 is the intercept, okay, and okay, sorry. Here it's not correct written. Okay, so B0 is the intercept. Yeah, it's right, and B1 is the slope. Okay, as I told you. Here, and then okay, the E is the predicate number. Okay, from the error number. Okay. So this is here the right, okay, measurement, okay, or the predicate measurement, okay, and this is here the real measurement, okay. So how far away they are from each other, this will be there, okay. This will be there, and our goal here, or our objective, to minimize the sum of square root, okay, to minimize this distance, okay, to minimize this distance between y0 and y1, okay.
Yes.
So between yi and y comma, okay. So this is here our objective, to minimize this distance between the both. So let us speak about residual now. What is residual? As I told you, residual is this error, this distance between the real value and the linear regressions, the value on linear regression, okay? And so the sum of square error, okay? The sum of square error or residual sum of square error, so they are the difference. Sum of square error is SSE, okay? This is the sum of all error together. And the sum of residuals or residual sum of square error is only, okay, the difference between yi from y, okay, from y. So, again, to explain it in a better way, to make it understandable, okay? What is the difference between sum of square error and the sum of, did you know? Okay, sum of square error and sum of residual, or residual sum of square. Did you know what is this difference between them?
Please to explain more.
Yes, okay. So here we have the residual sum of square. Okay, residual sum of square, it will be, we subtract yi from y cap and then square it and take the sum together. This will be RSS, residual sum of square. But total sample variability, okay, it will be y minus y, okay?
Yes.
Square, okay? So what is y cap here? This is SST. What is the y cap? Y cap is the mean, okay?
Yes.
So
Statistical.
that mean it's the difference from the mean, okay? But RSS is the difference from the linear.
The linear.
Okay, this is the difference between SSE and RSS. Okay. So the mean squared error, we will get it by dividing it by n. Okay. If we have population, we divide it by n. If we have sample, we are going to divide it by n. Okay. And this is here the. So let's move to the next idea, which told us how to estimate or how we estimation of RRS. So now goal of regressions is to minimize RMS, okay? And we know that if we want to minimize, so we have to take the derivative, okay? So we take the derivative by y0, okay? And this the derivative have to be equal to the 0, okay? And by rearranging this equation, so we will get the sum of y equal b0n plus b0 sum of x, and the sum of x I equal b0 x1 plus b1 x2. What is the meaning of this here in statistics? Did you know? Anyone can answer me what is the meaning? We already take it in our statistic course before.
Yes, you are right. That's to remember.
So we speak already about this issue here on our statistic course. Did you remember what was? Who remember that?
Stand the median with the sample.
Here, how we calculate the regression, okay? Here we are, the sum of y is b0, n is the number of the samples, okay? Plus b1 from the sum of the all samples. This is here comes from linear regression equation. But the second one, okay, it's here statistical formula, which here considers the correlation between two variables, if you remember, the correlation of two variables. Okay,
Yes.
so again, the first one, okay, it just comes from divided by n. Okay, so it just comes from linear regression equation. It will be the mean of y equal b0 plus b1, the mean of x. Why we take the mean? We divide it by n. If we divide it by n, it's the sum of y divided by n, it's the mean of y.
The mean.
And the sum of x divided by n, we take the mean of x. So, and then we multiply by the mean of x again, so we get this form.
Dr. Right, this is
Okay.
this will explain that mean the linear regression in the scope of the statistic.
Yes, this is from statistic. Okay, and then here here we divide by n. Again, it's here, then the sum of xi, yi, it's the correlation between x and y. And then it's equal b0 x plus b1 x squared over, okay? And from both equations together, if we combine them together, okay, so substitute here, subtract the equation from each other, okay? So we get here this formula, so x minus x bar multiply y minus y bar, okay, divided by x, the sum of the x minus x bar squared. Okay, how we get this formula here? We want to calculate B1. We subtract formula from each other. They have common factor B1. This common factor, it will come out, okay? Then we have here the sum of x squared minus the sum of x squared divided by n, okay? And which, okay. Okay, so this both will come out, okay, and B1, okay. Then we divide it by the sum of x squared over n over the sum of x over n, okay. And after that, so it's actually, if we remember, this is the covariance of xy divided by the standard deviation, the variance of x divided by the variance of. Or in another word, okay, another word is another formula for this formula, okay. We subtract here from xi the mean, and from hyi we subtract the y, and then divided by xi minus the mean. So what that mean? If the slope is positive, so it will be bigger than 0. It will be positive correlations. If this B1 is negative, so it will be negative correlation between them. If it's 0, then there's no relationship. If it's 0, that means there is here no relationship between them. And so this is here the we take here why regression, what till now, what is the regressions and why it's useful and how linear regression work in concept and mathematics. Okay, what is residual, what is RLS, what is the normal equation. Let us here finish here our lecture. Okay, after we define that B1 is the covariance of xy divided by the variance of x. Okay, and then we told that if B1 bigger than 0, that it's positive correlation, x increase, y increase together, B1 is smaller than 0, it's negative correlation, and B0, the intercept represents the value of y when x equals 0. And if we remove V0, then the line will be forced through the origin, which might not fit the real world data. Now, let's take an example, okay? A small example, how we are going to use the statistic on the linear algebra, okay? And we are going to program it by Python, okay? This will be your assignment, okay? So let's see here our example at first. It was here. So as we define here the linear regressions, let's go to the examples. Here we have here two variable. Okay, variable 1 is x1, 1, 2, 3, 4, 5, and variable 2 is 2, 4, 6, 8, 10. Okay, and then we have y. What you can see here, what is the relationship between x1 and x2? There is a relationship between them.
Yes, it's clear that the x2 is x1 multiple 2 or
Multiple 2, yeah.
x2 times.
Perfect. Okay. So so there is here a collinearity between them. Okay. So now let's set up this data set together. We are going to calculate XTX. Okay. XTX has to be non-invertible. Okay. As we remember, we are going to calculate XTX. Okay. And then we are going to calculate the determinant, okay, of XTX if it's 0, okay. That means it's non-invertible, okay. And in this case, the matrix cannot be invertible, okay. So in this case, okay, we take mean of x1, mean of x2, okay, standard deviation of x1 and standard deviation of x2. Then, okay, so mean of x1, how we calculate the mean of x1? We add them together and divide it by 5. Okay, add 1, 2, 3, 4, 5 together and divide it by 5. Then we add 2, 4, 6, 8, 10 together and divide it by 5. Okay, and same to the standard deviations. After that, here, let's calculate the x standardized. Okay, x standardized, how we calculate it? If you remember, okay, we subtract from hx, okay, the mu, the mean, and divided it by standard. Okay. So we are going to okay, standardize x here in this thing. Now we are going to calculate covariance again. Okay, covariance, it will be 1 over n minus 1. X at standardization BXT. Okay. When you calculate it here, you will get 1. Why we will get 1? Because as we see, we have the same column RB. Let's see if when you multiply them together, XT by X, so it will be 1. Okay. Now we compute the eigenvalue and eigenvector as we learned here in our statistic course, and then the eigenvalue will be 2 and 0. So we will consider 2. Okay, the eigenvector will be this value. After that, okay, so we calculate Z. Okay, from the eigenvalue we are going to calculate Z. Okay, so Z, it will be X multiply the eigenvector. Okay, and then after that, okay, we are going to calculate the linear regressions. Okay, which will be here ZT Z. Okay, the inverse of ZTZ. Multiply by ZTY. Okay, so we compute at first ZTZ. Okay, it will be 6. Okay, then ZTY, it will be 26. Okay, and then we are going to estimate beta, which will be equal to 4.472, and predicate at make predication. So for predication Z multiply beta. And we will get here this predication. Okay. And we can then program it by Python or by MATLAB, okay, to get the right answers. Okay, I want to mention if we are going to use ChatGPT, okay, it will make some mistake here. Okay, there is here an error. We will speak about this error next time, inshallah, and we will apply it more to our this example more to practice it, inshallah. Okay.
Thank you.
So, any question?
Thank you so much.
Thank you for attendance today, and see you, inshallah, by next time.